So today we're going to do uh, geometry and mainly angles. So all different kinds of angles and stuff we do with angles. So first, before we actually get into the angles, I want to define a few things. So a line segment, feels so cold today, I can't write properly. My hands are freezing right now. So a line segment is essentially a straight path that has two endpoints. So if this point is A, we call it A, and then this point is B, then connect the dots, and that's a line segment. So we call that line segment AB. And then something other than a line segment, there's something called ray. So like a sun ray. And if you can imagine with the sun ray, you have the sun, and then the rays just go everywhere. So it is a straight path that has one endpoint. So if this is A, then this goes on for infinity. So it goes on and on and on. Well, we often like to put a B over here. So we call this way AB, but essentially it's just from A and then traveling all the way to infinity. And then the other one is a line. So a straight path has no endpoint. Oh yeah, and for those people who have been in this class before the summer, uh, we if you can remember, we actually had this lesson before, so it's a good review for those who have had this. But so a line, we still do like an AB, two dots, but then now it's like going to infinity on both sides. So these are the three types of straight path, if you can imagine. So a line segment is with two endpoints, and then a ray has one endpoint, and a line has no endpoint, so it just goes on and on. Yeah. So these are the type of lines, and then with lines, or specifically rays actually, we create an angle. So two rays, so rays are these, remember, two rays that share a common origin or endpoint. If so, common origin. So this would be an origin. Creates an angle. So So if this is an origin, then you have two ways. And then what's in between this here is an angle. Yeah, so since this is a way, right? So no, I mean these are ways. That means you technically you have to draw like another dot, another two dots here, because a way is defined as this. But then like for when you do an actual question with a lot of angles, nobody actually does that. We just leave it at that. Like just one dot and then two. And oftentimes we don't even draw the arrows. Like, oh, I can't delete it. But yeah, oftentimes we just like angle and then mark it as an angle. So an angle is a rotation of the waist. So rotation, so this one, like take this for example, right? When you rotate this, so let's say we keep this the same, like on this line, and you rotate it this way, the angle gets bigger. And then rotate it more, like rotate, like let's say I rotate it here. Oh, then this is a big angle. So like the angle is a rotation bit of the waist. So well, you can rotate this one as well. So you can rotate it here, and the angles get even bigger. Or you rotate it like backward, and then you get a really small angle now. So an angle is a rotation of the waist. Okay. Uh, so yeah, maybe I'll draw it out. So from so the original angle, and then if you rotate it this way, so this arrow indicates a rotation, you essentially form a new angle. You form a new angle here. Okay. So the different types of angles. So first there's an acute angle. So an acute angle is like where you have an angle that is less than 90 degree. So this angle here, so less than 90 degree. So what is this 90 degree? Well, when you have an angle that is exactly 90 degrees, you get a right angle. So a right angle is just like so two ways that are perpendicular. So perpendicular means they're exactly 90. So it's like yeah, it's just like that, 90 degrees. So it's equal to 90 degrees. So right angle is equal to 90 degrees. It's like a rectangle, the corner of a rectangle or a square. And then we often like to indicate a right angle, specifically indicate a right angle with like this square thing at the corner over here. And then what is bigger than a right angle is obtuse angle. So obtuse angle, oh, is where the angle, oh god, there. So this angle, it is yeah, so It's bigger than 90 degrees. So this is let's say this is angle X, okay? So you still need some algebra here, but mostly geometry. So it's bigger than this angle, but it is smaller than 180 degrees. And then I will also define what is 180 degrees. So 180 degrees is what we call a straight angle now. So straight angle is actually just visually, like looking at it, it's a straight line. But what is essentially happening is like when you look at this, right? This angle here. If you can imagine that it rotates it enough. So maybe actually I'll draw here. So let's say initially you have an angle that looks like this, right? Like that is the original angle. Now I rotate it. So I rotate it. So this one, this way. This, let's say this blue way. I rotate it, rotate it, rotate it, rotate it, rotate it. Oh, all the way to here. All the way to here. So this blue way becomes like exactly flat. So this entire rotation, including this, so from here, entire rotation, this is 180 degrees. So this is why it's called a straight angle, because it's essentially just a straight path, except it's an actual angle, not just a straight path. So that is a 180-degree angle. Yeah. What? Okay, I'll draw again. So here, straight angle. And then we often, so if this is the origin, right? We indicate a straight angle with this semicircle, so half circle thing. And then, so obtuse angle is anywhere between this and this. So like this is a straight angle here, anything here, here, here. That's an obtuse angle. And then we can actually rotate this even further, right? So like, why stop here? Why stop at a straight line? We rotate it even further. And then when we rotate it even further, we call it reflex angle. I don't know why it's called that, but it's just what it's called. So from a straight angle, so this is a straight angle. Now we go even further. So it becomes here. So you can say that on this side is an obtuse angle, but what we are focused on is the rotation on this side, right? Since an angle is a rotation. So the rotation on this side is like this. So this is where it is greater than 180 degrees, but it's smaller than 360 degrees. And 360 degrees is, oh, what is it called? Oh, but it's just like a full rotation. So, wait, no, actually, yeah, my bad. All the angles greater than 180 degrees is called reflex angle. And then a special type of reflex angle is when you rotate it all the way around, right? So imagine this way, it rotates all the way around such that it goes back to this position again. So this here is a full rotation. And a full rotation is exactly double the 180. So that is equal to 360 degrees. 360 degrees. And then you can actually rotate this even more. So another circle, and then it becomes 360 times 2, which is 720 degrees. So it might not look like, it doesn't look straight, like why would you rotate it more than 360? Well, it has applications in the future. We're going to look at that later. But anyway, so any angle that is greater than 180 degrees, maybe write it this way. So greater than 180 degrees is called reflex angle. And then the special type is when you rotate it all the way around. And that is a full rotation. And that is called, and that, well, not called anything special, but it's 360 degrees. Okay? So these are the 5 types of angles. So acute angle, less than 90 degrees, and it's bigger than 0 degrees. So from here to there. And the right angle is exactly 90 degrees. And an obtuse angle is between 90 degrees and 180 degrees. And then with 180 degrees, you have a straight angle. So a straight line is 180 degrees. And then when you go above 180 degrees, you get a reflex angle. So you spin it around and around and around. Okay? So, any questions? Pretty simple, I think, right? Just all definition stuff. Okay, so now the 2 type of angle that we want to mainly focus on are actually uh, right angle and straight angles because they are really helpful when you look closely, examine them. So with these angles, we actually have like another concept related to them. So it's what is called okay, this line. So complementary angles and supplementary. Uh, complementary angles. Okay, so complementary angles. This is when you have 2 or more angles adding up to 90 degrees. Okay, so an example of that is, so let's say this angle here is so I'll draw it like this actually. So let's say this angle is 28 degrees, okay? So it's not 28 degrees, but I'm saying that it is because it looks pretty close to 28 degrees. And then you have another angle here. Now this one, if you wanted to sum up to 90 degrees, this one will be 62 degrees. Now when you add them together, what happens, right? So you get, when you add them together, you get this 28 degrees here. Oh, something like this. So 28 degrees. And then you have this 62 degrees. So 62, and then this is 28. So then all together, they form a 90-degree angle. So these are 2 angles. You can have more than 2 angles. Like you can have this, 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 and this. And then when you add them together, so all these angles added together, as long as they form a 90-degree angle, these 4 angles they are called complementary angles to each other. And then supplementary angles is when you have supplementary angles. So when you have two or more angles adding up to 180 degrees. So similar idea as this, except you are adding up to a straight path, straight line. So 180 degrees, right? Kind of like a straight line. So how you do this is like, so imagine this angle here is 40 degrees. So then if you have another angle that is 140 degrees, then when you combine them, so this is 140, and then you put it together with that 40-degree angles. Now this big angle over here, this entire angle, it becomes 180 degrees. And that is the definition of supplementary angles. So two or more angles, and again, you can have more than two angles, added together such that they form a straight path. So let me highlight this. So this here becomes a 90-degree angle, and then this here becomes a 180-degree angle. Okay? So any questions about complementary angles and supplementary angles? Concerns? Issues? No? Well, if you don't have questions for me, then I have questions for you. So, example. So one angle is 36 degrees. What degree is the other angle if they are complementary angles? So when you figure out, type it into the chat. Yes, 54. Good job. So you can just kind of take it like 90 minus 36 is 54. But then of course you can set up an equation. 90 depends on what you like. If you want, you can set up the equation. Or you can just say 90 minus 36 is 54. It's almost like an overkill to set up equations, but then sometimes when you get to more complicated problems, you actually kind of have to. But we'll look into that later. And then another example, let's say, so I have, something like this. So this, and then this, this, 136. What is this angle? 44. Wow, James, 1,000? 44, yeah. Yeah, easy. Wait, yes, 44. Yeah, so it doesn't add up to 190 degrees, okay? It adds up to 180. Complement, right angle is 90 degrees, but straight angle is 180. What is that, Nobel? Triggered? Why? Okay. Um, so let's look at something different maybe? So this here is, let's say 120. So what is this big angle over here? Mm-hmm. Yeah, good job, good job, good job. So a full rotation, a circle. Yeah, so next time when you see like a dot like this, a circle is 360 degrees. So then just 360 minus 120, 240 degrees, degrees, degrees. Okay, easy. So how about this? So example. So this is 8 degrees and this is 8 degrees. So I'll just say that these two angles, they are equal. And this here is 44 degrees. So what are these two angles? Yeah, doesn't look so good, does it? So let's just write 8 degrees, 8 degrees. 68. 128? Yeah, 68. How do you get 128, James? Oh, you deleted it. Okay. Yep, 68 it is. So this is where you have to use a bit of equation solving. Because so 8 degrees plus 8 degrees is plus 44 degrees is equal to 180 degrees. So then 2a plus 44 is equal to 180. So then 2a is equal to 136, right? Yeah, 136. So then a is equal to 68. Okay, good. I think everyone is getting the hang of this. So now with this, we can move on to so yeah, another concepts. So here, what I draw here is two lines, they intersect. So here what I have is two straight lines. that intersect. Okay, and then what I want to focus on is this angle and this angle. Now, so I'm going to tell you right now that these two angles, so the two opposite angles, so the red angle and the blue angle, they are equal. Okay, they are exactly equal the blue angle. So if this here is 36 degrees, this here will be 36 degrees. And then similarly, the green angle will be equal to the yellow. Oh God, that is huge. Is equal to the yellow angle. So now we can prove this using algebra, but then we won't get into that because we haven't talked about. It has something to do with systems of equation. So where you have like equations of different variables, but we will get into that later when we get there. But I'm just telling you right now that when you have two straight lines that intersect, so straight lines, okay? So something like this, that doesn't work. Like this angle, these two angles are not equal. It has to be two straight lines that intersect, okay? Then the opposite angles, they are equal. And then what they are called is a pair of vertical angles. A pair of vertical angles. So that's the word, vertical angles. So for example, I'll just quickly do one since it's pretty straightforward. Like, let's say this one is 136 degrees, and this here must also be equal to 136 degrees. They're always equal, okay? So this is, so right now we have defined the different types of angle, and then we looked at complementary and supplementary angles. So, and then some examples, and then now we looked at vertical angles. So two straight lines that intersect, the opposite angles must be equal. And so now, before we get to other angles, other types of angles, I'm going to define something first. So parallel lines. So you might know this already, but parallel lines are lines that never intersect with each other. So now how we denote this is like, say we have two parallel lines. Actually, I'm going to draw it with a ruler. Now, so actually, yeah, so it'll just be like this. So it doesn't have to be like flat or vertical, as long as they're like this. These two can be two parallel lines because they never intersect, right? So how we indicate this is by drawing like kind of like actually something like this. So maybe like two arrows here and then two arrows here. So why we want to do that is because, like, let's say I draw another pair over here, right? So like I draw a red one here, and then a red one here. Oh, the red one and the black one, they are not parallel. They're definitely not parallel. They intersect right here, right here, right here, right here. But then the red ones themselves, they are parallel. So then we might want to draw like 3 arrows now to indicate that they are like two different parallelity. So the black ones are parallel in this way, and the red ones are parallel in this way. So that's why we draw like the triple arrows here, and then the double angle here. So just something to keep note of. And then, yeah, so these two lines are always the same distance from each other. So this distance is the same as this, okay? So pretty straightforward, I think. So with a parallel line, we can form different angles. So let's say here, I have a parallel line, two parallel lines. Oh God. Now by themselves, you don't see any angles. But what I can do is to draw in a line like this. This is a line that goes to both parallel lines. And now this blue line here is called a transversal. So just keep note of this name because I'm going to refer to this name a lot. But this here is a transversal line. So this line here is called a transversal. And oh yeah, and these two lines, let me indicate that they are parallel. Okay. So with this, we have essentially how many types of angle? Let's see. 1, 2, 3. Yeah, about 3 types of angles that we can form here. So all the angles here are 1, 2, 3, 4, 5, 6, 7, 8. There are eight angles over here, and some of them are very special. So I'm going to tell you first that this angle over here, and then this angle over here, they are equal. So the red one is called alternate interior angles. And alternate interior angles are equal. So how I recognize interior angles actually. Wait, actually, let me just draw this bigger, okay? Because I'm going to do a lot more drawing on here. So angles are really, like, this concept is really visual. So if you like the visual stuff, then I think you're going to like this more than the proportion. A lot of drawing. Some algebra, but yeah, so this here is a transversal. Okay, so alternate interior angles. How you can recognize this is by the Z. It's kind of like a Z, right? So actually, maybe let me use a highlighter to make it more clear. So, oh, that's way too thick. Okay. See? So when you have the Z, then this angle and this angle, they are equal. Now, the other type of angle now is called corresponding angles. So corresponding angles are these ones. So this one and this one. So they are on the same side of the transversal, right? So whereas the alternate interior angles, they are on different sides. One is on the right side, one is on the left side. But for corresponding angles, so these are what is called, they are on the same side of the transversal, except they are on different parallel lines. So the green ones are corresponding angles, and corresponding angles are equal. Okay. And then the final type I'm going to talk about today is the, oh yeah, so for this one, you can kind of visualize like this. So like it's kind of like a C, I guess. Yeah, something like this. Oh, it's getting a bit messy. I'm going to delete it. So I'm going to delete the red highlighter as well. So these two are alternate interiors, and then these two are corresponding. And the final type is called uh, uh wait, same side interior, yes. So same side, yeah. Choose purple. Same side interior angles. So these two. So I think it's very obvious that they are not equal. One is an acute angle, and then one is an obtuse angle. But what is special about them is that same side interior angles are supplementary. So again, what does that mean? They add up to 180 degrees. Same side interior angles are supplementary. So add up to 180 degrees. So yeah, so that is essentially it. So how you recognize this is like, well, it's just inside the C. Whereas the corresponding angles, one is inside the C, one is outside the C. But I think you can kind of recognize that this angle and this angle is the same. It looks the same, right? Whereas this one doesn't look the same, but then they are supplementary, so they add up to 180 degrees. And then the red one is the Z. Recognize it as Z. And the purple one as like the inside this thing over here. Yeah. And the green one is just the not much pattern you can, but yeah, just like that. Okay. So today that's all the concepts I'm going to go over for today, and then maybe just some example. So just assume that these two lines are parallel, okay? So I'm going to call this A, B, C, D, E, F, G, H. So tell me, which angles are alternate interior angles? So find all the alternate interior angles for me. There are one, two, yeah, two pairs. So A, B, C, D, E, F, G, H. which pair of angles are alternate interior, like in this diagram here? You can find the set, and then you can find it. B, okay. Oh, you no. CF, is it? Mm-hmm. Okay. DG. Yes. GB. G and B. Well, well, G and B, they are equal. Yes, they are equal. But they are not alternate interior angles. Because like alternate interior, right? Like by the name interior, it means inside. So like it's inside the parallel lines. It must be inside the parallel lines. But G and B are equal, yes. But they're just not called that. But yeah, so the set is either this. So this is the set. And then there's actually another set. A distorted one, you can say. It's not really a set, but like it's the same idea. Like you go there, there, and there. So D and E, they are in the red set. So D and ah, D and E are alternate interior angles, right? AIA. And then C and F are AIA as well. So now how about same side interior angles? So what are the sets of same side interior angles? So maybe let me pull up the definitions again. There. Yeah. So oh, it's actually 11 already. So actually let me just point it out then. Yeah, just quickly go through this. So yeah, D and E, they are same side interior angles. Uh, and then C and E. No, D and F, I mean. Yeah, my bad. D and F. And then C and E. They're same side interior. And then the corresponding angles, A and E, oh, there are actually a lot more corresponding angles. So A and E are corresponding. And then C and G are corresponding. And then B and F are corresponding. And then D and H are corresponding. Okay? Yeah, so that's essentially it for today.